You craft MuonClip, it tames Muon's fire with QK-Clip. 15.5T tokens trained, no loss spike. You realize stability and efficiency can dance. You build a MOE Beast, 1.04T total, 32B activated. Sparsity scaled, 384 experts sing, you see less can do more with smarts. You synthesize agentic data, 3K real tools, 20K synthetic born, trajectories woven from task and rubric, simulation shakes hands with real execution, you watch tool use bloom, no real world bind. You mix RL with Verve, rewards you can check, and self-critique too. The model learns to judge its own steps, token budgets balanced, no ramble bloat, you find alignment beyond the static page. You test it hard. 66.1 on Tau2, 76.5 on ACE, 65.8 on SWE-Bench Verified, 47.3 Multilingual, 53.7 on LiveCode, 75.1 on GPQA Diamond. It outruns open peers, nips at closed heels. You open the checkpoints, they say, but it's just 32B activated. You show the leaderboards, the real-world votes. Top open source, 5th overall, they mumble, but Agentic is hard. You step back, it's not just a model, it's a bridge from static data to dynamic action, from pre-trained priors to real-world doing. You realize you didn't build another LLM, you built a foundation for agentic intelligence that will learn, adapt, act in every environment yet to be, and they go quiet. Welcome to the deep dive. Today, we're really getting into some fascinating territory. Agentic intelligence, we're looking at these new developments that let AI, learn, adapt, and act in ways we're frankly just starting to wrap our heads around.
That intro, it paints quite the epic picture, doesn't it? Stability and efficiency can dance. Let me tell you, from inside the lab, it sometimes feels less like dancing and more like trying to stop a runaway train before the whole system just crushes itself.
Right. Not quite so elegant behind the scenes.
Not always. But, that rap actually does a great job hinting at the sheer technical difficulty and ultimately the achievement behind Kimi K2. So our mission here today is to unpack Kimi K2, which is this really impressive open source model, figure out how they pulled it off, and understand why people are calling it a foundation for this agentic intelligence.
Okay.
We'll focus on those key breakthroughs, the innovations that, kept that train on the tracks and really push things forward.
All right, let's start at the beginning then. Before you can get an AI to act intelligently, you just need to train it without it blowing up. I read about this issue with the Muon optimizer, something about exploding attention logic. Sounds problematic.
Oh, it's a massive headache. Muon is, it's known for being incredibly token efficient. It crunches through data really well, often better than standard optimizers like AdamW. But the catch is, especially when you scale up to these enormous sizes, things can get unstable.
How unstable?
Like the internal values and the attention mechanism, the logics, they can suddenly skyrocket, just completely explode numerically. And when that happens, your model training collapses. It just fails.
Yikes. So how did Kimi K2 tame that beast?
They came up with something called MuonClip. It's essentially a clever combination of Muon and a new technique they developed, QK-Clip.
QK-Clip. What does that do exactly?
Think of it as a governor, maybe? It rescales the query and key projection weights after each update. So basically, it's constantly watching these internal signals, the things that determine focus. If they start getting too strong, too intense, QK-Clip gently scales them back down. It puts a bound on their growth.
Okay, so it prevents them from running away.
Exactly.
Yeah.
And the result was pretty staggering. They managed to pre-train Kimi K2 on, get this, 15.5 trillion tokens of data.
15.
Wow.
Yeah, a huge amount. And they did it without a single loss spike, without the training collapsing once. That stability isn't just a technical footnote, it's critical. It means you have a reliable foundation, a model that won't just break when you push it. And that's huge for you as a user, knowing the underlying tech is robust.
So stability handled, let's talk architecture. It's a mixture of experts model and MOE. That seems to be a really hot area right now.
Yeah.
How does Kimi K2 use that?
Right, MOEs are fascinating. They aim for that sweet spot. Massive capability, but also efficiency. Kimi K2 technically has over 1 trillion parameters, 1.04 trillion total.
Which sounds enormous.
It is, but here's the clever part. For any single piece of information it processes, it only actually activates about 32 billion of those parameters.
Okay, so only a fraction is working at any one time. Precisely. You can imagine it like a giant library with, say, 384 expert librarians, each specializing in something different. When you ask a question, the system intelligently routes it to maybe the 8 best experts for that specific query. Those 8 handle it. The other 376, they wait for a relevant question.
Ah, okay. That makes sense.
And the research showed this sparsity scaling law, activating just this small subset, this sparse group of experts, consistently lowered the error rate during training and testing. It proves that idea. Less can do more, if it's the right less, with smarts.
That's a really interesting trade-off. Less raw computation per query, but still accessing this huge knowledge base. Did they make other efficiency choices? I saw something about attention heads.
Yeah, that was another very practical decision. Some other big models, like DeepSeek V3, use 128 attention heads. Kimi K2 uses 64.
Why fewer?
Well, they tested it. And they found that doubling the heads from 64 to 128 gave only a tiny improvement in accuracy, like maybe 0.5% and 1.2%. But it increased the cost of running the model, the inference overhead, by a whopping 83%, especially for long inputs.
Ouch.
So diminishing returns.
Big time. So for agentic AI, where you need fast responses, even with lots of context, sticking to 64 heads makes the model much more efficient, much more practical. For you, this means a smarter model that doesn't need a supercomputer to run, giving you quicker answers.
Okay, stable, efficient, but how does it learn to actually do things?
Yeah.
To use tools? That seems like the core of this agentic idea.
Exactly. This is where they really focused on building practical capabilities. They created this huge agentic data synthesis pipeline. Think of it as a specialized training program just for teaching AI how to use tools effectively.
Like software tools, APIs.
Yep, exactly. It starts with tool spec generation. They gathered specs for over 3,000 real-world tools. But then, and this is clever, they used AI to generate specifications for over 20,000 synthetic tools.
Wow, why synthetic ones?
To create immense diversity. It exposes the AI to a much, much wider range of potential tool structures and functions than just relying on existing ones. It builds broader understanding.
Okay, so it has this massive toolbox, real and imagined. What next? Then comes agent and task generation. They synthesized thousands of different AI agents, gave each one a specific set of tools from that huge collection, and assigned them tasks. Crucially, these tasks came with explicit rubrics, clear definitions of what success looks like.
So the AI knows the goal.
Right. And the final stage is trajectory generation. This is where they simulate realistic back-and-forth scenarios. They had other AIs play the role of users, creating natural conversations, and the Kimi K2 model would have to figure out which tools to use, when, and how. A sophisticated simulator would then execute the tool calls and provide realistic feedback.
Like a flight simulator, but for using software tools.
Kind of, yeah. But they didn't just rely on simulation. For really critical things, especially coding, they used a hybrid approach. They complemented the simulations with execution in real sandboxed environments.
So checking it against reality.
Exactly. That combination gives you both the massive scale and diversity of simulation, plus the grounding and authenticity of real execution. And that's how tool use blooms. It lets the AI learn to handle complex multi-step tasks in the real world, like debugging code or managing systems, not just answering trivia. That's a huge step up for you as a user.
It really sounds like it. But just learning from examples isn't always enough, right? How does it refine those skills, get better over time? The rap mentioned mixing RL with Verve.
Yeah, reinforcement learning, RL, is key here. It's often much better than just supervised learning for mastering complex actions, because the model learns from the consequences of its actions, from trial and error, essentially.
So learning by doing.
Pretty much.
Yeah.
Kimi K2 uses a couple of smart RL approaches. First, for tasks where there's a clear right or wrong answer. Think math problems, logical reasoning, checking code. They use a verifiable rewards gem. The system can objectively check if the answer is correct or the code works, and give a clear reward signal. Simple and effective for objective tasks.
Okay, but what about fuzzier things? Like, is this explanation helpful? Is this creative?
That's where the second part comes in, the self-critique rubric reward mechanism. This is really cool. For subjective qualities, the model learns to evaluate its own outputs.
It critiques itself.
Yes. It compares pairs of its own responses based on different criteria, core instructions, specific requirements, even feedback from human reviewers defined in these rubrics. It learns to identify which response is better according to those subjective guidelines. It's like building an internal taste or judgment mechanism.
So it's developing its own sense of quality.
In a way, yes. Guided by the rubrics, of course. This helps achieve alignment beyond the static page. It starts to understand nuance and preference, not just factual correctness.
That's pretty sophisticated. Any other RL tricks?
A couple of important ones. They added budget control. This puts a limit on how many tokens, basically how long the model's response can be for a given task. This stops it from rambling, generating super long answers when a short one would do. It encourages efficiency.
That sounds useful. I've definitely seen models get verbose.
Right. And they also use something called PTX loss. This is important to prevent catastrophic forgetting, making sure that as the model learns new things through RL, it doesn't accidentally overwrite or forget the valuable knowledge it gained during its initial pre-training.
Holding on to its core knowledge.
Exactly. So for you, all this RL means you're interacting with an AI that's not just trained on static data, but one that learns from doing, from feedback, and even from judging its own performance. It leads to more helpful, more intelligent, and frankly, more efficient interactions.
Okay, the tech sounds incredibly impressive. Stability, efficient architecture, sophisticated data synthesis, self-improving RL. But the proof is in the pudding, right? How does Kimi K2 actually perform when you test it hard?
Absolutely. And the results are genuinely strong. The instruction-tuned version, Kimi K2 Instruct, made quite a splash. As of mid-July 2025, it was ranked as the #1 open-source model on the LMSYS Arena leaderboard.
#1 open source, that's huge.
It is. And 5th overall, competing with proprietary models. Importantly, that's based on thousands of blind comparison votes from real users. It's a strong signal of real-world preference.
Okay, what about specific capabilities like coding and tool use?
It excels there. It hits state-of-the-art for open-source models on benchmarks like SWE-Bench Verified, that software engineering scoring 65.8%, also on the multilingual version, 47.3%. On Live Code Bench, another coding test, 53.7%. In many cases, it's outperforming not just other open models, but even some well-known closed-source ones. It's definitely nipping at closed heels.
And tool use specifically?
Setting new benchmarks there, too. On Taw2 Bench, it got 66.1%, and on 53.7%. In many cases, it's outperforming not just other open models, but even some well-known closed-source ones. It's definitely nipping at closed heels.
And tool use specifically?
Setting new benchmarks there, too. On Taw2 Bench, it got 66.1%, and on ACEBench, an impressive 76.5%. The paper notes it substantially outperforms all baselines on these agentic tool-using tasks.
So that line from the intro, they say, but it's just 32B activated, you show the leaderboards, that really rings true. The performance comes from the smart design, not just throwing trillions of parameters at every problem.
It's exactly right. It's about the efficiency of the MOE architecture and the quality of the agentic training. And it's not just specialized tasks. Its general capabilities are solid, too. High scores on MMLU, 89.5%, GPQA Diamond, 75.1%, and DROP for long context question answering, 93.5%. These numbers aren't just academic. They mean Kimi K2 can be a genuinely useful tool for you for complex coding, reasoning, and problem-solving tasks.
It sounds incredibly capable. But no model is perfect. Were there any limitations the researchers identified? It's always good to know the boundaries.
Definitely. And the team was transparent about them. One thing they noted is that for really hard reasoning tasks, or if the instructions for a tool aren't super clear, the model might generate too many tokens, basically, get stuck, or produce overly long attempts.
Okay, so it can struggle with ambiguity or extreme complexity.
Sometimes, yes, leading to truncated or incomplete outputs. Another interesting point, its performance can actually decrease if you force it to use tools when it doesn't really need to.
So don't give it a hammer if it doesn't need to nail anything.
Pretty much. It's powerful with tools, but activating them unnecessarily isn't always optimal. They also found that just giving it a one-shot prompt like, write me a whole software project, isn't as effective as using it within a proper agentic framework, where it can break the task down, use tools iteratively, etc.
Use the tool as intended.
Right. And one final point they mentioned that due to how some benchmarks are set up, it might occasionally seem overly confident in areas where the answer is actually ambiguous. So a potential to overstate certainty.
That's helpful context. Knowing the strengths and these potential weaknesses helps you, the user, understand how to best interact with it, when to rely on it, and maybe when to double-check or provide more guidance. So we've journeyed through the core innovations of Kimi K2 taming training and stability, the clever MOE design, the massive effort in synthetic data for tool use, and the advanced reinforcement learning. It really does feel like more than just another iteration of an LLM. It feels like that bridge the intro mentioned from static information to dynamic action.
I think that's a fair assessment. It represents a significant step towards AI that doesn't just process information, but can actually act upon it, use tools, learn from interaction in a more sophisticated way. It brings us back to that final idea from our wrap.
You realize you didn't build another LLM. You built a foundation for agentic intelligence that will learn, adapt, act in every environment yet to be. It's a powerful concept.
It really is. Building that foundation is the crucial step.
And thinking about this, it leads to a fascinating thought for you, our listener. If an AI like Kimi K2 can now learn so effectively from interaction, from verifiable results, and even from self-critique using defined rubrics, what could that imply for us, for human learning?
Interesting angle.
Could we, as individuals, apply similar ideas? Maybe define our own self-critique rubrics for learning a new skill. Or apply budget controls to how we research or practice to avoid getting bogged down. How might we become more effective learners, more effective agents in our own lives by thinking about these principles of learning, adaptation, and focused action? Something to ponder.